Okay, this is super hard to see on the screen, but I'm going to make these much larger in a minute. So it says rewrite each expression. In parts A and B, write your answers without negative exponents. So my answer can't have negative exponents. And then for part C and D, write your answer in scientific notation at the end. So let's go ahead and look at part A. First of all, I think we're getting to a point where we know shortcuts for dealing with negative exponents. But I'm going to step us through, the long cut, the way that we reason through it. So if I look at 2 to the negative third power, I know that I can make that, I can neutralize a negative exponent by multiplying this by 2 to the third. Now I got to be careful because that would definitely change the value of this expression. But if I multiply it by 2 to the third over to 2 to the third, it doesn't change its value at all because this is just a giant 1. But I leave the giant 1, and if you look, if I multiply this numerator, 2 to the negative third times 2 to the positive third, that's 2 to the 0 power, which is 1. And then in my denominator, I've got 2 to the positive third. So 2 to the negative third power is the same as 1 over 2 to the third. So I think you can see the shortcut there. So I can take this and I can rewrite this as 50 times 1 over 2 to the third power. I can also take this and, rewrite it as 50 over the number 8 or 50 over 2 to the third. And I can definitely reduce that, right? Both of those are divisible by 2, so I can write it as 25 over 4, for example. So probably any of these would be okay. In fact, 50 divided by 2 to the third would be a fine answer also. I've written it without a negative exponent. If I'm trying to simplify this completely, probably this is the answer that I'd be most satisfied with. So let's look at part B. There's a negative exponent there down in my denominator. And honestly, I like to deal with that first, but I think I'm going to deal with this first. So I've got a to the third and a in my numerator, and I've got a to the fourth in the denominator. So if I rewrite this, right, this becomes a to the fourth power times b squared over, and I'm going to change the order of these, a to the fourth power times b to the negative second power. This is a giant 1. Notice my exponents are exactly the same, a to the fourth, a to the fourth. So that equals 1. So now we're looking at b squared, b to the second over b to the negative second. Well, to neutralize this negative exponent in my denominator, I'm going to multiply by b to the second and times b to the second, right? So here's a new giant 1 I'm introducing. My denominator now is b to the 0 power, or, which is just the number 1, right? So my denominator is just the number 1. And my numerator is b squared times b squared, or b to the fourth power. So that's my answer, right? I would write this as just plain old b raised to the fourth power. Again, no negative exponents there. Probably an error I've seen far too many times that makes me sad and cry is, if students see this, you might be tempted to just call that 1. It's not, right? It has to be the exact same thing divided by itself. And b to the negative second is not the same as b to the second, so be careful there. All right, number C. Or letter C, rather. It's a letter. It says this said rewrite your final answer in scientific notation. So let me go ahead and I can deal with my exponents here. If I have b to the negative third and times 10 to the second, I basically add those exponents, right? So if I add those exponents, I end up with 10 to the negative 1. So 10 to the negative 1 accounts for this 10 to the negative third and 10 to the second. So that's that part. But then let me deal with the decimals here. And excuse me, I'm sorry, this is goofy that I'm doing this, but I'll just ask someone. What's 2.3 times 4.2? Oh yeah, it didn't get the 2.3 right. Let me try it one more time. What's 2.3 times 4.2? I'm embarrassed to say that it's not hearing the 0.3 right, so let me try this just with my calculator. Okay, so when I do that, I got 9, whoops, I don't want a highlighter, I got 9.66. And if I look at this answer, this is in scientific notation, right? I've got just a leading decimal, a leading integer in front, a single digit integer in front of the decimal point, and it's written as the power of 10. So this is 9.66 times 10 to the negative first power. In scientific notation, this is our answer. And again, this 9.66 is nothing more than the product of 4.2 and 2.3. If it turned out when I did that I got something that had, let's say it was like 12.5, I would have to remove the decimal place and change my power of 10. But as it was, this was perfect. On this next one, I'm going to use the definition of an exponent to rewrite this. So this is equivalent to a 3.5 times 10 to the third times a 3.5 times a 10 to the third. So if I look at my 10 to the thirds, right, this becomes 10 to the sixth power. So 10 to the sixth is part of my answer. Well, actually, it might not be. I might have to modify this. Let's look at 3.5 times 3.5. Well, and you can see this is where it happened. I got 12.25 when I multiply those two values. This number is not in scientific notation. I need to, and this is not supposed to be equals anyways, it's supposed to be times. I need to move this decimal place. So if I look at this, I need it to be here, 1.225. Now, if I multiply that by a 10, I want you to understand that everything that I just wrote, right, 12.5 is the same thing as 1.225 times 10. Those are equivalent to each other. And then over here I've got it times 10 to the sixth power. So what I'm going to do is, I'm just going to bring this 10 to the first and 10 to the sixth together. My final answer will be 1.225 times 10 to the seventh power. So there we go.